Hello, hey everyone. Thank you so much for joining another edition of Trailhead Live today. My name is Mohit. I'm a developer evangelist here at Salesforce. So today we're going to talk about the Heroku Dev Tools and Salesforce data model. So this is our second episode of modern app development on Salesforce. Now, before I introduce you, Julian, let's do some housekeeping items here. So forward-looking statement, please do not make any purchasing decisions based on anything forward-looking that we'll make in this presentation. Now, over to you, Julian. I know that last time we had audio issues. Looks like we resolved it, and our audience is really happy. I must say to hear you. So, over to you, Julian.
Of course, thank you, Mohit, for inviting me to this Trailhead Live session and all of the series. There is a lot of beautiful content that we have to share with you all. For the people that doesn't know me, my name is Julian Duque. I'm a lead developer advocate here at Salesforce, working mainly with the Heroku team. I've been working with JavaScript for a while, like since 2011, and I'm trying to bring all of my JavaScript and Node.js expertise to you, the Salesforce community. I've been a Node.js contributor, part of the open source core project, and also a Node.js promoter and evangelist, and being involved with a lot of different communities, mainly in Latin America. And I organize a couple of conferences in Colombia, my home country. One is the JSConf, the JavaScript conference, and the other is the NodeConf, the official Node conference in Colombia.
Awesome. Thank you so much, Julian, for the introduction. I'll go next. A lot of you know me, but if you do not know me, my name is Mohit Srivastava. I'm a developer evangelist here at Salesforce, and I've been working with Salesforce technology for a decade now, primarily building system integrations and enterprise applications. Also have a experience around building ISV applications as well on Salesforce for App Exchange. Now, this series is again a 10-part series. In our first episode, we covered around Salesforce development tools like Salesforce CLI, Scratch Arcs, and all of the ways to build Salesforce application. We will share the recordings for that. It will be up next week. And last week we had some audio issues. We have rectified that, and hopefully everything will go smooth from here on. So today we'll be doing, Heroku app development. We'll be listening to Julian, and we'll be seeing, where Heroku adds, value into your enterprise architecture. So Julian will be talking about Heroku CLI, how to build a web process, a Node web app, how to deploy it. So all of that. So we have excellent content. And then, next week we have a couple more sessions, which is basically talking about front-end application design, and also we will look into Heroku add-ons and databases, etc. So really excited for this series. Again, I just want to take some time to make sure I convey the objectives of this series. Feel free to share your feedback. Again, we want our Salesforce developers to be familiar with modern development practices with respect to tools, with respect to technologies like Node, JavaScript, and also if you're a Heroku developer, we want to showcase the clicks and code capabilities on the Salesforce platform. Now, if you're a new developer, welcome to our ecosystem. Thank you so much for being part of the ecosystem and exploring our technologies here. So for you, we will take you through the journey of designing, building, testing, and deploying application on Salesforce platform. So with that, Julian, I think we will move on to deploying a Node app on Heroku using Heroku CLI. So I'm so excited about it, Julian. And Julian, over to you.
Okay, I'm excited as well. Can you share my screen, please?
Yes.
Awesome. So remember on our previous session, we were having like some minor technical issues. Now I'm going to be reminding you what we need to do to follow up with this content. I'm still not seeing my
Just
my
give me
screen.
a sec. Yeah,
Okay.
sure.
So the first thing we need to have is an Heroku account. So we need to have an Heroku account. So you can go directly to heroku.com, and there you will find a button for signing up for a Heroku account for free. You will not need to enter any credit card information for the Heroku account. But if you do, we are not going to charge you anything, but we will give you more hours in the month. If you don't add a credit card, you will be able to have like 500 hours to run a web application. But if you put your credit card, you will be able to have 1,000 hours. That means you will be able to have a full web application running for the whole month, and the rest of the hours can be used to run a worker process. And later we are going to see what a worker process is. So pretty much go to Heroku.com, click on sign up for free, fill out your information, make sure you select your specific role. You can be a professional developer or a hobbyist if you want to try Heroku and to start like playing with it. Second, you will need to have certain things installed. So I'm going to take you to this website. This website is called the Dev Center, which is the house of our documentation. Here at the center, you are going to find all of the information relating to Heroku. On this main page, we are going to select the programming language we are going to use. Remember that we told you that Heroku supports 8 official open source programming languages, from Node.js, Ruby, Python to Java and Go, and other that are shown in there, and other programming languages that are supported through the community. So there are other members of the community that have created build packs, which is the technology behind the detection and running of the application on Heroku, and you will be able to pick those. But these are going to be the ones we officially support. For this demonstration, we are going to use Node.js. We are going to create a Lightning Web Components open source application that uses Node.js, and we will deploy that application to Heroku. So first and foremost, you are going to follow this tutorial. Go and click on Node.js. Let's click on Get Started with Node.js, and it will take you to a step-by-step process, and you will learn everything about Heroku and how it works. When you click I am ready to start, here are the prerequisites. So you will need to have Git installed, the same control version manager system that you are going to need for using SFDX or for using the Salesforce tools to deploy an application to the Salesforce platform. And also you will need to install the Heroku CLI, which is the developer tool that allows you to control Heroku from the command line. You will find the installers for macOS, Windows, or Linux, depending on the operating system you are using. And it's going to be pretty much a similar process while installing the SFDX tools on your computer. And now that you have everything ready, let me show you in the terminal how can you check that you have Heroku installed. Also, since we are going to be working with a Node.js application, I will recommend you to install Node.js. You can go to nodejs.org and click on the LTS version. LTS means long-term support, which is the version that Node.js has like stable and ready for production. So you are going to install this also on your computer, and then we are going to be ready to go. Let's go to the terminal. Here, it's where I'm going to be starting with my application. I'm checking that I have Node.js installed, executing the node command and the -b flag, which gives me the version. And the same with the Heroku command line tool. With the -b, it's going to tell me that I have Heroku installed and that it's the latest version of the CLI. Second, I will need to log into my Heroku account. I'm not going to follow that process because I am already logged in, but pretty much you will need to type Heroku login. It will open a web browser window, and from there you are going to type your credentials, and then you get like a automatic token that lets you log in on the terminal. After you are logged in, you are going to check if definitely you are logged in into the platform. I'm using the Heroku Who Am I command, and it's telling me that I have logged in with my user. So this is my user. I am logged in on the platform. Cool. I can start working with an application. Similar to creating a Salesforce application, we are going to bootstrap an application using Lightning Web Components open source. For that, let's go to the following website that I have open here, LWC.dev, which is the house of Lightning Web Components and the Lightning Web Components open source. And we are going to run this first command. So what this command does, it is using NPM, which is the package manager for Node.js and JavaScript, where you are going to find all of the different libraries, plugins, and modules for the JavaScript ecosystem. And npx is a runner. It's going to let you execute a command that is deployed on npm, and that command is create LWC app. This is a generator or a scaffold program that is going to create a basic project for you. And then you will specify the name of your application. So let me copy this command, go to the terminal, and I'm going to create my first Heroku LWC app. This is going to fetch the create LWC app generator from npm, and it's going to fetch all of the different dependencies, and we'll start pretty much a CLI tool that will ask me certain questions like what is the name of your application, what type of application do you want to build, uh, certain different options. So
Julian,
now we are,
Julian,
yes,
do you mind answering a couple of questions for me as a Salesforce developer? I have some couple of
of
questions for.
of course, of
So
course.
why did you like sort of choose npx and like usually node commands we see it's npm, right? In this case it
Okay.
was npx. Like I'm curious to know why did you choose like npx there?
Yeah, there are like two different ways of dealing with global modules. What
Okay.
is a global module in npm? It is something that you install that it's an executable. It's something that you run on your computer. So one way to do it is by installing that command as a global,
Got
and the
it.
command will persist in my operating system. So it
Okay.
will persist, and I will be able to have access to create the LWC app always on my computer.
Got it.
MPX, what it does is it's going to execute, create LWC app without installing it in your computer. This is like for one-shot executions.
Got
Let's
it.
say I don't want to install this command. I just want to bootstrap an application and that's it. You use npx for that. It's the npm executor or the npm runner and comes with Node.js.
Awesome. Okay. Great.
Oh,
Sorry for disturbing
no,
your
please
workflow.
ask me
Yeah.
all of your questions. And if you see any question on the chat, for example, Avid
Yes.
is telling me when can we support Swift? Right now, we don't have official support for Swift, and I don't think we are going to be adding official support for Swift. But we have the Heroku Elements, which is a marketplace where people from the community and other third-party companies can also create add-ons for Heroku. So I'm not sure if we have Swift support, but I'm going to click on the build pack section. And on the build pack section, we are going to find support for other different languages. So let's check if there is Swift support. There is a couple of build packs that support Swift. There is one from IBM, for example. There is some others created from other developers. You might want to find the one with more forks or stars or likes. Let's say this one from Kyle, and it has the instruction of how can you add Swift support to your Heroku application. This is a community contributed build pack. So if you are finding any issue, we can support that issue. You will need to reach out to the developer that created support for this language. So that's
Yeah.
how Heroku works.
Yeah, it looks like add-ons are pretty similar to our App Exchange in Salesforce. On App Exchange, we publish applications, which might be from, different software vendors, or it can be from, let's say, Salesforce Labs, but we don't really support them. It's up to the vendor to support. So,
Exactly. So the community has a lot of different support. For example, we don't have official .NET support, but there are like a good build pack in the community that you can use and create ASP applications on the Heroku platform, for example.
yeah, and
So
Julian, maybe this is not for this conversation, right? But if our developers want to like sort of understand how to build a build pack, right? Maybe we can share some links for them, for those developers who are really curious about how to build a web pack. So.
definitely. So build packs, it's a technology that we created at Heroku that
Mhm.
right now is part of the Cloud Native Foundation, and it's a standard pretty much.
Got
So if
it.
you go to buildpacks.io, you are going to find a lot of different information on how to create a build pack and add support for your favorite language, or why not extending the Node.js build pack to add some tool that is not supported by default. Great questions for this session. So let's continue bootstrapping our Lightning Web Component application. Let's follow a simple setup. Our name for the application is going to be my first Heroku LWC app. We are going to select here that we want to create a standard web application, but with Lightning Web Components, you will be able to also create a progressive web application or an Electron application. An Electron application is a desktop application similar to Visual Studio Code. Visual Studio Code is a application built using Node.js and JavaScript that runs as a desktop application in your computer. So you will be able to use Lightning Web Components for the same purpose. But since Heroku is for web applications mainly, we are going to create a web application, in this case, a standard web application. It asks us if we need an Express API server. So far, we don't need it. The application that we are creating already comes with a server, so we don't need this step. And now it is creating the project and fetching all of the different dependencies from NPM. If you see, it is fetching all of the plugins that Lightning Web Components needs in order to run. Since this is going to take some time, I already have a project here that I created and it's compiled, so we will be able to play with it. Do you have any question, Mo?
Yeah. So I had one question, Julian, is, this LWC app, right? The create LWC app that you use to scaffold this project, right? It seems like it's a command line application. So is it also built using Node technology and JavaScript?
Exactly. It's also built using Node and JavaScript as well. So if it lives on NPM, I will say that 99.9% of the application that lives on NPM are written using JavaScript, because that's the package repository for JavaScript.
Awesome.
You might find a couple of other things that are built with C and C++, but that's why, or that's because.
Looks like we lost Julian. I'm gonna retry reaching out to him. Just give me a sec here. We'll be back. I'm just gonna try finding Julian. Oh, it seems like Julian is back while his screen is not back. Okay, looks like we lost Julian's audio as well. Just gonna try adding. Just gonna reach out to Julian here.
Okay, I am.
You are back. You're back, Julian. For some reason we lost you. We lost the signal for some reason for some time.
Yeah, but are you still seeing my screen?
Yeah.
Oh, fantastic. Yeah, I was able to recover myself from this crash.
Okay.
Awesome. So now we are running the application locally here. Let me keep open the chat. Perfect. Now we are on localhost on the port 3001, and we have the Lightning Web Component application that comes by default. Okay. Now we need to put this application on Heroku. How can we do this? So first, let me stop this. Open the Visual Studio Code. We are going to be doing everything from Visual Studio Code. So first, for deploying an Heroku application, you will need to have an application on a Git repository. So this application here, Lightning Web Components Open Source already does this for you. It's a Git repository, so I'm good with this requirement. This is because Heroku is Git-based. So in order to make a deploy to Heroku, you will need to have a Git repository, and you are going to use Git to put that application online. Second, we need to create a space to deploy our application. And for that, we are going to use the Heroku CLI to create that space. So similar to the Salesforce CLI tool, Heroku has the help flag that will allow you to take a look at the different commands and subcommands that Heroku supports. One of the commands that we want to check is the apps command. It's the one that lets you do all of the different application management on Heroku. So this is also built using Oakleaf. We already talked about Oakleaf, so it's going to be the similar pattern as you see in the SFDX tool. And here we can see that we can create a new application. And also, if we take a look at the help for this command, you can see all of the different options that you can pass. So pretty much you can specify a name for your application, or you can leave it blank. If you leave your application pretty much the Heroku apps create, or its alias, which is Heroku create for simplicity purposes, and you leave it blank, it will automatically generate a name for you. So we have like a name generator for applications. If you specify a name, that name needs to be unique within the full Heroku platform, because we are a multi-tenant service and there are like more people running applications on Heroku. So you will need to come with a unique name for your application, or let Heroku create that name for you. I'm going to let Heroku create the name for me. Sometimes we get some funny names here. So let's run Heroku create. It's creating an application, and now it gives me an URL. So my application, after I deploy, will live in this URL, quiet lowlands 31016. So let me open the application. And right now we don't have anything there. It is empty. We need to deploy an application there.
Got it. So
Second,
this is before you go ahead, Julian. So this looks like, it's a unique domain that got created, right? And what to me was interesting was when you created this, right? So this is also your production kind of an environment, right? Like unlike in Salesforce, we create like a scratch arcs, right? So I wanted to
It
understand a bit.
depends. It depends.
Okay.
You can
Okay.
treat it as a staging, you can treat it as a development, you can
Got
treat
it.
it as a production. Later in the series, we are going to be talking about the Heroku pipeline or Heroku flow, when we are going to have those roles way more defined. Right now, that depends of what you need. And let's say that we are going to be treating this as a development environment,
Got it.
but for the technical purposes of the presentation, it also works as production as well. So that's something that we are going to be discussing further in the series.
Perfect.
I have my space. Second, I need to check that I have the remote on my Git repository pointing to this Git server that we have here. For that, I'm going to execute git remote and the flag -b, which means verbose. And it is telling us that we have a remote called Heroku living on that specific Git server. That means that we can deploy an application. Make sure you have a commit that you are going to be putting pretty much on Heroku before you do the Git push. There is another file that is very important, and it is the proc file. And I already created a proc file in here. What is this proc file? For the majority of reasons, Heroku is going to detect the type of application you are deploying. If it's a Python, PHP, Java, Go, etc., it's going to auto-detect the application and is going to follow the default mechanism to start that application. In the case of Node.js applications, that will be the npm start command. Where does these commands live? Node.js project have a file called the package.json, which is like the manifest file for Node.js project, similar to the SFDX project file that lives on a SFDX project. And here on the script section, you are going to see the different commands that can be executed to run a Node.js app. If we see we don't have a script, we have a script that it's called serve. Serve is the one that runs the Node.js server. This server lives here on the scripts folder. This is for a Lightning Web Component application, but if you are using another different Node.js application, this might be different. And here we are going to see the code, which is an Express application that serves the Lightning Web Component app that we want on Heroku. So the command that we need to run on Heroku to serve this application is going to be npm run serve. This is what we are going to add on the proc file. We are specifying that our web process is going to be executed using the npm run serve command. Okay, we have the file. This file, I created this file. This file doesn't come with a LWC app, so you will need to create this file and add this line. And then making sure you have everything on the Git repository. You already created a commit. And at the end, what we need to do is to execute git push Heroku main. I'm using the name of the branch that I have on my repository. In this case, I'm using main, but sometimes you might find certain repositories that are using the master branch. Main became like the new default at GitHub, so this is what we are using. So after we do the git push Heroku main, this is what happens. Heroku receives your code and it detects that it is a Node.js application. So the build pack, like the Node.js build pack, is going to bootstrap your application, run all of the build process, which means that it's going to install all of the different dependencies into the node modules folder. This is fetching all of the dependencies you specify on the package.json. And I'm going to be showing here on the package.json how that looks like. You see that we have some dependencies in here. These are the ones that are needed to run this application on production. And these dev dependencies are the ones needed to build your application. Those are going to be removed on production as well. And let's take a look at the building process. We install all of the different dependencies. We are building the project. Now we have a Lightning Web Component application built. Then we are pruning the dev dependencies. We don't need the dev dependencies on production because we already built the process. And what this is doing, it's building a container image, which we call as log. A container image is something, it's a term used on cloud native applications. Pretty much is like a unit that contains your application and a basic operating system that is going to run on a container server. And after we create that image, it's going to be deployed to a Heroku dyno. And an Heroku dyno, it's the minimum compute unit where you are running an Heroku application. So it is a unit that has certain amount of CPU and memory allocated where you are going to run your web process. So after we build our application, Heroku discovered that we have a web processing here. It created an image, which has like 36.2 megabytes. This is the container image that is going to be put on the dyno. And it's releasing that dyno. Pretty much it's creating a release, it's launching the application. And now I can go to this URL and see my changes. So you can do this on two different actions. You can click the link, or I can easily refresh the link I already had previously loaded. And now we have the Lightning Web Component application deployed. Or for simplicity, you can execute the Heroku Open and it will open the application that you deploy in there. So that's how can you deploy a Node.js or any other application to Heroku.
Yeah, so Julian, I have a couple of questions for you, right?
Sure.
So one thing is you talked about this dyno concept. It's pretty new to Salesforce developers. I don't think we have any concept of dynos for us. It's like we get a limited amount of CPU, it's just 10 seconds, and we have to code all our process within that. Otherwise, we take the process asynchronous, right? So talk us a bit about dynos, can we scale them? What is horizontal scaling? What is vertical scaling? And yeah, let's talk through that.
Awesome. So as I say, a dyno, it's a compute unit that is going to be used to run an application on Heroku. And normally specifically for a Node.js application, there are not going to be a lot of different requirements because Node.js applications are very lightweight.
Hmm.
But there are other applications that might require more CPU or more memory, or let's say we are running a heavy process that is doing some ETL data manipulation and that needs a lot of CPU. So we also offer different dyno sizes. So
Got it.
normally what I'm getting here is a Hobby Dev dyno. A Hobby Dev dyno, it's a free dyno, so it doesn't cost anything for me, where I can run my web application. It is limited on CPU and memory, but it's good for an application that is not getting a bunch of traffic or a lot of
Hmm.
concurrent users. The next step is using a Hobby Dyno. So the Hobby Dyno, it's a dyno that I need to pay. The price, I guess it's $7 a month. And the difference between a Hobby Dev Dyno and a Hobby Dyno is that the Hobby Dyno, the one I'm paying for, never goes to sleep. A
Got
Hobby
it.
Dev Dyno, the free one, if my application is not getting any traffic, Heroku, what it does is that put that dyno to sleep so it doesn't consume any resources. And after a new request comes in, the application is going to wake up.
Got it.
The main problem or the main issue people face is that that waking up process might take a couple of seconds. And if you
Hmm.
know, a couple of seconds might be a lot for a time response in a web application because our users might want to get results fast.
Yeah.
But for a hobby application, if I'm learning about Heroku, I don't care about that time, to be
Got
honest.
it.
So that's the main difference between the free and the paid version. The rest, they are going to be the same and allow you to have applications. Now we have other different layers or sizes of dynos. Now let's see, we are working on a production application that have more users and that we might require some other features like auto scaling.
Hmm.
So we have the standard dyno. The standard dyno has two different types, the 1x and 2x. And the main difference is the amount of CPU and memory that those dynos has. And the other one, it's going to be the performance M and L, which are going to be the dynos that are with more CPU, more memory. They are perfect for Java applications, for examples. And they also support auto scaling. And we are going to be taking a look at how can we scale applications on Heroku.
Hmm.
There are two different types of scaling in computer science. You can scale an application by using vertical scaling. Vertical scaling is adding more compute power to the same machine, pretty
Hmm.
much increasing the size of the machine or throwing
Got it.
more money to the problem, as I say. So
Hmm.
I'm adding more CPU and more memory, and that's it. The other one is horizontal scaling. Horizontal scaling, it's more for concurrent users or for supporting more
Got it.
users coming to my application. And that means that I have multiple applications, pretty much the same application, but
Right.
running multiple times.
Hmm.
And I have something on front of those applications that routes all of the incoming requests to each of one of the different machines or computers. In our case, to one of the different dynos.
Got it.
So that is the Heroku router. You don't need to do anything about that. We
Hmm.
maintain and we manage that. That's the key of Heroku. We make your life easier by dealing with the infrastructure problems,
Amazing.
and you just need to focus on the business and your application. And you will be able to also slide, like pretty much on the dashboard, slide a component and say,
Right.
okay, I want my application running on 10 dynos, and that's it. That's how
Right.
easy you can do scaling. Or you can do it on the CLI tool, and we are going to take a look at an example. All of the things I can do on the CLI can be done on the Heroku dashboard. So let's go to Heroku dashboard. This is the dashboard.heroku.com. After I log in, I have access to my applications. And we can see here that the quiet lowlands, the application we created, it's a Node.js application. I go and click on my app. I can see all of the different activity. We just deployed
Hmm.
that application. My application is using a free dyno, so I'm not paying anything. This is the command that we executed. And we can see here on the resources that we have a free dyno. Let's say
Got
that
it.
we might want to upgrade this dyno to a standard dyno. I'm
Nice.
clicking on change, and I'm picking up a standard dyno here. So let's go to the professional tier. I'm running a production application. Now this is going to start like costing a little bit more money,
Hmm.
but it's worth it. Now, how can I vertical scale? By moving this component here. Pretty
Got it.
much, I click here and I can move from 1x to 2x. The difference is going to be the amount of RAM, or I can use the dedicated dynos, which are going to have like more RAM, but obviously it's going to cost more.
Got it.
So I'm on a standard dyno right now. My application it's running on a standard dyno. I didn't do anything. It
Yep.
automatically creates a new release. I redeploy this application on the standard dyno.
Right.
And if I want to scale, I can go and click on this edit button
Hmm.
and slide this. Let's say I want to run on 10 dynos.
Yep.
And now my application is running on 10 dynos.
Got it.
Boom. I did it's as easy as it. Let me take a look at the same operation on the Heroku CLI. Let's
Yep.
go to the terminal here. We are going to be using the PS command, which means process. And I execute the process command, and it's telling us, hey, your web process, it's using a standard 1x dyno, and you have 10 different processes here.
Got it. So there are 10 different requests. That means when I say
No,
when
this
you
is
say
this is 10 different dynos that are
dinos.
dealing with requests.
Got
So
it.
let's say if I have 1,000 users right
Hmm.
now coming to my application, the router is going to send 10 use like 100 users to one dyno,
One.
100
Got it.
users to the other dyno. So the dynos are not getting all of the load. The load is
Right.
being distributed or balanced. This term
Got it.
in computer science terms, it's called load balancing.
Load balancing. Yeah.
Load balancing. You can also modify the name of or the number of dynos from the CLI. You can scale like upscale or downscale by using the Heroku PS command. So
Hmm.
let's say I'm going to scale the web process back to 2 dynos.
Okay.
And if I execute Heroku PS, I'm just seeing 2 dynos.
Got
If
it.
I refresh the browser here, instead of 10,
It'll be
I'm
two
going to
dinos.
see
Two dinos.
2 dynos.
Perfect.
There is another feature that it's available on the performance dynos, which is the
Hmm.
auto scaling. So I'm
Auto scale.
changing right now to performance dyno.
Hmm.
And what is auto scaling? Normally, Heroku scales depending of the response time. So
Got it.
if our application is doing a lot of operations and it's taking a lot of traffic, the response time is going to increase. What is the response time? When I do a request, the application is doing an operation and then returns that result. If that
Got it.
response time is higher than certain threshold, I might want to start adding more dynos to my application to decrease that response time. So
Got
if
it.
I enable auto scaling, I can say, okay, my range is going to be between 2 and 5 dynos. Let's see, this is my scale for my range for scaling my application, and my desired response time for the percentile 95 of the request is going to be 1,000 milliseconds. They recommend to do 500 milliseconds.
500.
Depending of your needs, you might tweak this number. Take into account that this might be a cost feature, a expensive feature. If you
Hmm.
tweak these, and if you don't know your application, you might start like auto scaling and getting a bigger bill.
Bigger.
But knowing the application, testing for performance before enabling these will let you know like the desired response time. So I can confirm that I want auto scale. And if I start adding traffic to my application and if I reach that threshold, this is going to scale automatically for me.
Perfect. Awesome. So what this means, again, I'll summarize this for Salesforce developers because I know that all of these is new to them. So what this means is, let's say you have a Salesforce application and you have like a microservice running on
Mhm.
Heroku. which basically reaches out into Salesforce or extracts data from Salesforce, right? You generally go for vertical scaling in that terms, because you don't need more compute here.
Mhm.
You don't need more machines here. You need your more CPU, because it's a long running process. So it might take a lot of CPU. So you need that. But let's say you have a web application, right, which every user in Salesforce is sort of requesting. Let's say we have 100 Salesforce users, 50 of them trying to access this Heroku
Mhm.
application simultaneously, right? In that
Yep.
sense, you need this horizontal scaling, because you need more number of essentially dynos, so that you can handle those
Exactly.
many requests. And also, let's say you're running an event or a campaign, and you have a page which, let's say, it's going to be accessed by thousands of users or 10,000s of users at the same time. You might want to sort of use the horizontal scaling to make sure that your application doesn't crashes.
Yeah. To finalize, because we are running out of time for your topic, uh, we talk about web processes, but you can
Yeah.
also have worker processes, which are processes that doesn't need a web application. Pretty much are processes that are running. Maybe it's a one-off execution, or it's something that you are going to be executing
Right.
for doing certain operations. I'm going to teach you how to add a worker process to a node application or to any other application. So first, I'm going to create a node script called say hello. And this script here, say hello, is going to do a simple operation. I'm going to put a set interval, which
Hmm.
executes a function every certain time, let's say every 3 seconds. And this is going to do something as simple as hello, Salesforce developers. I have the worker process here. If I execute this locally, you are going to see that this is going to say hello every 3 seconds. So this is
Yeah.
working. Thank you very much. What I need to do is to map that process on the proc file. So I'm
Hmm.
creating a new process, hello, and that hello process is going to execute that say hello.js script, and
All
that's
right.
it. I need to add the file, commit the file, add worker, and after this is added, I can deploy to Heroku, and that's it. I have a new process that I can execute, that I can scale as well, and it will be running on a dyno, and it will be executing every 3 seconds the say hello command.
Awesome.
Back to
Yeah.
you, Mo.
Yeah, this is, I mean, when I saw, like, your code, right? Like, especially the node code that you're writing, you use the same folder, essentially same local project to create both, the web process or the web worker, and also your web application. Right now, that's so powerful. And also you showed how to use using Node.js. Now that's really powerful, because what happens is in Salesforce, right? We know that we use a lot of batch effects for long running processes, and we sort of put a lot of a lot of stretch on the application. I think we lost Julian. Anyways, that shouldn't be a problem, because I'll be running the other set of slides. But yeah, continuing the conversation, for Salesforce developers, right? The It seems like the web worker process seems to be very useful to do some resource intensive applications on Heroku, rather than using batch Apex, which might basically doesn't have like an SLA on Salesforce. Okay, with that, so we completed this activity that we couldn't in the last session, right? Now with that, I want to move on to the data model design in Salesforce here, and let's look at the data model design in Salesforce. I think we have like what 10 minutes, so I'm going to go through the slides, and then essentially in the next session maybe we're going to do some hands-on, and we'll also have Julian sort of explaining us some of the database add-ons like Postgres, etc. So that's going to be interesting. Anyway, so I'm going to go ahead with data model overview. So again, now this might be a repetition for a lot of you Salesforce developers, because you do this day in day out. But for Heroku developers out there, or who are new to the platform, I thought I'll put some slides and explain, what is a data model. So in Salesforce, right, data model plays a lot of a role in your application. Any Salesforce application that you build, you'll build data model. So, and these are attached, like we have standard objects which are attached to licenses. So essentially, depending on what you purchase, what licenses you purchase, will give you a lot of standard objects. Like for example, if you purchase Sales Cloud license, we give you accounts, contacts, opportunities, cases, price book, and all other things that you need for a sales operation. Similarly, we have for Service Cloud. So depending on what you need Salesforce for, you will essentially see you'll essentially take the application here, right? Like you'll get these standard objects, right? Now if you want to create, like extend these standard objects, we give you custom fields, so you can extend them with custom fields. Now let's say you have a specific requirement where you have your own attributes and none of these standard objects sort of fit into picture, right? And that's where you go for like a custom object here. Now, we'll also look at something like external objects and big objects. So Salesforce also has this concept of external objects, where what you can do is it's very similar to custom object, except that the data, right, is stored outside Salesforce, can be sort of visualized with the same list views, with the same record layouts in Salesforce. So this is so useful, specifically with something like Heroku Connect, that we'll look at it, where we'll have like a Heroku Connect essentially, and what Heroku Connect can do is it can expose an external basically an external object, and Salesforce can consume it. And then we have big objects. So big objects is specifically designed for large data volumes, and it doesn't have all these capabilities like custom objects. But let's say you're tracking something like history tracking, or you're auditing something, and you do not want to take the data outside Salesforce for compliance reason. That's where we give sort of a big object here. And also you can take analytics on big objects by doing an async sockle, and again, you won't be able to use standard reports and dashboards, but you can use tools like Tableau, CRM to do that. Now, other thing that I want to talk about here is object relationships. So for a lot of you Heroku developers out there, right, if you're thinking about Salesforce, this becomes like a really big deal, because your application scalability completely depends on how you define relationship between objects. So for example, let's say you're defining a master detail relationship, and I'll show you with an example maybe in the next session how to sort of create objects and how to link them using using the clicks and schema builder and other clicks capability of the platform. But essentially, your master detail relationship, right? So in master detail relationships, right, objects are tightly coupled, and we have the security feature in Salesforce where your record level sharing. So for example, you can set the visibility of the records to the row level in Salesforce. So for master detail relationships, right, one of the core aspects is your child cannot have a different sharing visibility. It has to follow whatever is there on the whatever is set up for the parent record. So it becomes tightly coupled, as I said. If you delete parent, the child automatically gets deleted. So you have less control over the child records, but it gives you some more flexibility, like roll up summary fields, etc. So that's what master detail is for. Very useful actually. If you know that your child objects will not have any visibility requirements, or if your child object strictly is governed by parent, you choose that. Otherwise, you choose lookup relationships. So lookup relationships gives you that sharing flexibility, and child records are not deleted upon deletion of parent records in lookup relationship, essentially. So that's the advantage of that. Now, I also want to take some time, for all of you Heroku developers out there, and even for Salesforce developers here, this is very important to understand, is your data model pretty much defines a lot of things in Salesforce. Like for example, your user interface, right? The fields that you see on the page layouts are all driven by data model, right? The field level security, like which fields to see, not, etc. Everything again is dependent on that object model that you create, right? Your profiles and permission sets, and then you can write automation on those objects, and then you can write code components which reference those objects. You can take reports and dashboards. So important thing here to understand is when you create an object or a field, right, it's very easy in Salesforce to do clicks with that, right? But really one of the things to note down is, it still has a dependency, and there are a lot of things that are taken behind the scenes. So you should always be taking care of your metadata and know what metadata is getting affected. We make it easy with Salesforce for source pull commands, and now we track the dependency. There's a way we source track whatever the clicks that you're doing in the org. So we'll take a look at that. And next session, and probably this will be the next session, where I will be essentially creating a scratch arc, showing you how to like create a data model and then retrieve it in your local folder. And then essentially this application, right, eCards, we're going to explore a bit more in upcoming sessions, where we'll look into integration. So you can find that eCards application on our Trailhead Git repo. So you can go to github.com, Trailhead apps. It's going to ask me for a SAML here. Anyways, so you will find it here, and if you go to eCars, this is one of the application which uses a lot of integration endpoints with Heroku, and that's why I picked this application for this series. But we're gonna basically explore this application in depth in upcoming sessions, where we will see how it uses Apache Kafka, how it uses some of the Heroku microservices, and how to create like a Lightning Web Component, and sort of today Julian went through like basics of it, right? But we'll see in more depth of how real world applications like progressive web applications can be deployed. So you can also explore by yourself by going to the Trailhead apps and exploring all of our sample gallery apps. Again, this activity is on me. Next session, definitely I'll cover them. We'll also have Julian sort of working with us for Heroku add-ons, etc. And now here are some helpful references we pulled from last two sessions, and I'll share this slide on this chatter group. So again, join this chatter group. I'm gonna if you can take the screenshot, I'm gonna also put this in the chat window here. But yeah, feel free to like join this group. We'll share the slides, and feel free to ask questions to us about application development on Salesforce, on Heroku, and we'll make sure that we address all your queries here. Okay, I think we are running out of time. I know that there is the next session sort of planned. But yeah, do share your feedback with us. We have our Twitter handles there. Unfortunately, we lost Julian's camera and the screens today. We'll see if we can make sure that it doesn't happen next time. But yeah, feel free to share your feedback. We got through the content that we had for today, and really looking forward to the next sessions next week, and also sessions in December and January, and hopefully if you have some requests, please do make it on our chatter group. We'll keep monitoring it, and we'll bring those topics as we discuss modern app development on Salesforce. Now with that, I want to take some time and thank you so much for being part of the community. Again, share your feedbacks, and looking forward to sort of have you on other sessions as well. Thank you. See you next time.